everybody. Mrs. Bodechon here. Thank you for joining me for Science Read-Alouds. Today we will be reading Little Books of Big Facts, Physics, written by Belle Richardson. Heat. Liquid. What is physics? In a field of physics, scientists examine matter, energy, and the ways that things interact. Solid. Matter is all things that take up space, which includes all liquids, solids, and gases. Energy is something that can be transferred between matter. Energy can do work when it is transferred. Kinetic energy is for things in motion. The kinetic energy between atoms causes thermal energy, which transfers as heat. There is also chemical energy, electrical energy, nuclear energy, and many other types. Would a ball thrown through the air have kinetic energy? Yes, because the ball is in motion. What is an atom? It is a unit of matter. Each atom has 3 parts: protons, neutrons, and electrons. The middle of an atom is called the nucleus, and the protons and neutrons are inside. Electrons are in sets of shells around the outside. Atoms from different elements have different amounts of protons, neutrons, and electrons, which changes how they interact with each other. There are also isotopes, where atoms of certain element have the same amount of protons but different amounts of neutrons. Understanding atoms has led to both devastating and spectacular technology. Did Albert Einstein make the atomic bomb? No, but his theories were what made the research possible. Why are time, mass, and distance important in physics? Since we can measure and record time, mass, and distance, this helps us with understanding when and how energy is transferred and transformed. From recording these known factors, we can make calculations for how energy moves and changes. As an example, think about Newton's cradle. If you only lift the first ball a short distance, it lightly taps the rest. If you draw it up high, when the ball comes down, it transfers more energy through the matter and sends the end ball flying. Why might testing time be important? Time can help us to calculate speed. What are heat and work in physics? Heat and work are forms of energy transfer. Heat happens as a result of kinetic energy when the atoms are moving around. When heat is transferred from one system to another, it goes from the hotter one to the colder one, like how holding a warm drink sends heat into our hands. Work happens when something is moved by force, like how you can make your bike move by pedaling. Heat can transfer to work, and work can transfer to heat. When surfaces move against each other, we call it friction. Friction is work converted into heat, which is an example of friction with our bodies, jumping or skating. Skating is an example of friction as surfaces are moving against each other. What are forces? They affect objects in different ways depending on factors like mass and power. One very important force is gravity, which we measure by how objects accelerate as they fall. Understanding gravity has helped us to develop things like parachutes. It has also helped us to test how gravity behaves in water, which has led us to discover things about animals and to develop diving equipment. Jellyfish use gravity to know up from down. Jellyfish raised on the ISS didn't cope back on Earth. Why do you think this might be? In microgravity, the jellyfish did not develop the right gravity sensors. How do we see light and color? Physics also helps us to understand how light and color work. When we see color, our eyes are catching different wavelengths of light. We can see color from wavelengths 380 to 700 nanometers long. Violet is the shortest wavelength, then blue, green, yellow, orange, and red. Objects absorb a certain amount of light and reflect what we see as color. This has helped us to make dazzling colors with art and technology and understand how different animals see the world. What does it mean when someone is colorblind? Color blindness is when someone has difficulty telling certain colors apart. How do we hear sound? It travels in waves just like light does, but waves of sound and light are different. Sound waves are a pressure that travels through things like air and water. They start with a vibration in an object which causes its surroundings to also vibrate. It is traveling through air. It bunches and spreads air as it moves along. The waves travel to our eardrums, where our brain interprets these vibrations as sound. Just as it is with color, we hear at different frequencies to other animals. Can young people hear sound that adults can't? Yes, there are certain frequencies that only teenagers and children can hear. What does physics have to do with computers and other machines? Understanding energy transfer has helped us to go amazing places with technology. Computers started out the size of a room, and now we have smartphones that can do astounding things. Understanding electrical energy and how to efficiently conduct it has been very important for the development of CPUs, which send out electric pulses in computers. With physics, we have been able to expand the memory and processing power of our computers, the graphics of our video games, and what robots are capable of doing. Which is more powerful, the computers that used to take up a room in the 1960s or a smartphone? A smartphone is more powerful. What parts of physics can be explored in space? With time and research, physics has answered a lot of amazing questions about our universe and caused us to ask more. We can find planets by radiotelescopy, which measures wobbles in the light from stars, finding planets in that star's orbit. We know that the gas and ice giants in our solar system have many moons due to their enormous gravitational pull. We understand a lot about moon and planet formation and composition as well. However, there is still much to learn. Black holes are still largely a mystery, and there are many theories on the dark matter that holds our universe together. Is there a black hole at the center of our galaxy? Yes, there is a supermassive black hole at the center of our galaxy. How can physics help us with power and energy? Physics has also helped us to understand the way that we can consume power, how we can make this more efficient, and how we can get energy from renewable resources. Now that we are running out of fossil fuels, we must research new ways of generating and storing energy. In the beginning, getting power from the sun, wind, and waves was not as efficient as fossil fuels. However, as scientists make improvements and came to understand more about these new technologies, solar panels, wind turbines, and hydropower are quickly becoming the way forward. Can we make electricity from steam or hot water underground? Yes, this is called geothermal energy, and there are many such plants in the United States. Why can natural forms and disasters be explained by physics? Through the field of physics can help us to understand more about natural disasters and be able to predict where the damage might happen so that we can prepare. It is also possible to estimate how severe the damage might be so that we can have plans for evacuation and assistance. Why can natural forms and disasters be explained by physics? Through the field of physics can help us to understand more about natural disasters and be able to predict where the damage might happen so that we can prepare. It is also possible to estimate how severe the damage might be so that we can have plans for evacuation and assistance. We can also explore natural formations with physics. From the tallest mountain to the deepest ocean trench, physics can help us to understand how parts of our world were formed, as well as how life is different under varying pressures. The Mariana Trench is the deepest point under the sea. Is it lifeless down there? No, there are many animals that can survive in the Mariana Trench. What will physics do in the future? There are endless possibilities for scientists who study physics. Our universe is constantly expanding, and there are more planets and galaxies than we could ever map and understand. There are futures in energy-efficient structures and engines, robotics, medical science, and all sorts of technological aspirations that are currently only dreams. With each new invention or innovation, we are making the future. What do you think the future might hold? Are we already able to make artificial limbs that move? Yes, there is still a long way to go, but we are already making and improving on robotic limbs. That ends, you guys. I want to give a special thank you to BookBot Kids for sharing this public domain book with us. I hope y'all enjoyed this read. If y'all want to check out my new books that are coming out for Read Alouds, go ahead and click that subscribe button, and I hope you enjoyed the story. Bye, everybody.